Hello everyone, welcome to Maths Kitchen Homework Club. I think we're on number 6 now. It's very good to have you here. Thank you for joining me. So I'm James and I run Maths Kitchen, which is this Facebook page, and I've also got a YouTube channel, which is just YouTube/Maths Kitchen. And for both of those, the aim of them is to help you with your maths, whatever level you're at, more or less whatever age you're at really. I have a bit of a focus on kind of GCSE level and helping people through their exams, but I'm here to help anybody at all that needs help. So this week I'm going to be looking at how to simplify fractions and how to find the area of an amount, because those are things that people have requested from YouTube. So if you've got something you'd like me to look at, you can either mention it in the comments here on my Facebook page, or leave a comment under one of my videos on YouTube. I'll read them all, I respond to all of them. I really appreciate any feedback. It's really nice to have communication with people that are watching my videos, and there's only so much I can cover, but I'll do my best to help everyone out as quickly as I can. Good, right, let's get into it then. Perfect, right, Anyway, technology, as always, is a bit of a headache, but I'm hoping this works. I hope you can see me and you can see the whiteboard and everything going on. So the first thing I'm going to look at is the fractions, simplifying fractions. First thing that's really useful to know with fractions is that there's lots of different ways of thinking about them. So you can see these examples I've got here. That first one, 10/20ths. Well, you could think of 10/20ths as 10 out of 20, right? Those two things mean the exact same thing. 10/20ths or 10 out of 20. You could think of it as 10 divided by 20 as well. All three of those things mean the same thing and are just useful in different situations to help you think about it in different ways. So when I'm thinking about simplifying this fraction, we could think of an example. Let's say you've got 10 out of 20 people enjoy watching football, let's say. Okay, 10 out of 20. You've got a group of 20 people, 10 of them like football. Well, you could simplify that down to say that half of those people enjoy watching football. Okay, so 10 out of 20 simplifies down to a half. 1/2. Similarly, the second one, 50 out of 100. You can see that that's the exact same thing. If I've got 50 out of 100 people like football, we're just saying that half of those people like football. So 50 over 100, or 50 hundredths, or 50 out of 100 just means a half. And simplifying fractions is just the process of what I just did there, where you reduce those numbers, but you're not changing the actual value of anything. So 10/20ths is equal to a half. It's no different. If I said 10 out of 20 people like football, it's the same as saying half of the people like football. But the numbers aren't always that nice and straightforward, are they? So we need particular techniques to help us to simplify them down, particularly when the numbers are a bit harder. And really that comes down to having a good knowledge of your times tables and being able to find factors of numbers, which follows on from having a good knowledge of your times tables. So let's move on. I'll do a few more examples and I'll explain what I mean, and I'll show you the specific techniques. So number 3, you can see I've got 16/20. Where's my pen gone? There we go. So what you can do, really what we're trying to do is to divide both of the numbers in the fraction, that is the numerator, the number at the top, and the denominator, the number at the bottom. We want to divide them both by the same number. And you look at your fraction, in this case 16/20ths, and you think, well, what number can I divide both of those by? And the easiest number to divide other numbers by is 2, isn't it? So you can always start with that. Do both of these numbers divide by 2? Well, 16 divided by 2 is 8, and 20 divided by 2 is 10. So yes, both of those numbers divide by 2, so we can go ahead and do that, divide both of them by 2. Then we've got this new fraction, 8/10ths, or 8 out of 10, and we can repeat the process. Do those numbers divide by 2? And yes, they do, don't they? 8 divides by 2, which gives you 4, and 10 divides by 2, which gives you 5. So we end up with 4/5. Now, can we repeat that? Well, 4 divides by 2, but 5 doesn't. In fact, the only number that 5 can be divided by is 1 and 5. So we can't go any further with that. We can't simplify that fraction down anymore. So we say that that has been fully simplified. So we're just dividing, in this case we just divided by 2 and then divided by 2, and I'm going to see if I can do that for the second fraction, and then I'm going to get onto ones where it's a little bit more complicated where you can't do that, but I'll show you how to do those as well. So 28 over 20, well we've got a top heavy fraction here, but it doesn't matter, we're going to do the exact same process, okay? So 28 can be divided by 2, that gives us 14. 20 can be divided by 2, we've seen that already, that gives us 10. Then we've got 14 over 10, well they can both be divided by 2 as well, so we get 7 over 5, 7/5. Now neither of those numbers can be divided by a common, they can't both be divided by the same number again. There's no number that they will both divide by, so we have simplified that as far as we can. We've got 7/5. Well, if I put 5/5 together, that would be one whole. Imagine you've got pizza, split into fifths. When you put 5 of those pieces together, you've got one whole pizza. So we could say we've got one whole pizza, and there'd be 2 left over. So 1 and 2/5. That last step there, don't worry too much about that. That's a separate skill. It's not the focus of this homework. It's obviously a very useful thing to do, and almost certainly something I will come back to in a future homework club. Right, so that's that. Let's look at some slightly more complicated examples. Okay, moving on then. Number 5, we've got 18 over 42. Can both of these be divided by 2? Yes, they can. So 18 divided by 2 is 9. 42 divided by 2 is 21. And can both of these numbers in our new fraction, the 9/21ths, can they be divided by 2? No, they can't. They are not even numbers, so they don't divide by 2. Right, so now we're getting into it. So what do we need to do? We need to see whether they can be divided by another number. So they can't be divided by 2. Can they both be divided by 3? Well, 9 can be divided by 3, and 21 can be divided by 3, in fact. So yes, they can both be divided by 3. So if I divide 9 by 3, I get 3. If I divide 21 by 3, I get 7. So that simplifies down to 3/7. So it's not always that you just divide by 2. Sometimes you're going to have to divide by 3 or by another number completely. Right, number 6 then, I've got 30/40. 30 over 40. Now, I could go through the same process, dividing them by 2 and so on, but I can see straight away both of those numbers, because they end in a 0, I can tell that they are multiples of 10. Right, they're in the 10 times table, in other words. 30 is in a 10 times table, 40 is in a 10 times table. So both of those will divide by 10. So 30 divided by 10 is 3. 40 divided by 10 is 4. So we end up with 3/4. We have simplified that as far as we can. 45 over 50. 50 can be divided by 2, but 45 can't. So we're looking for another number that they both divide by. Well, I know that they're both in the 5 times table, and I know that because everything in the 5 times table ends with either a 5 or a 0. And both of these numbers do. So they're both in the 5 times table. So therefore I can divide them by 5. So 45 divided by 5 is 9. 50 divided by 5 is 10. And we have our simplified fraction. All of these, they have the exact same value. We're not changing the value. We're just writing it more simply with smaller numbers, essentially. That's what we're talking about. Right then, where's my next one? Here we go. 36/42. 36 over 42. Now, these could be divided by 2 actually, but I'm going to show you. Here's what I would do if I've got larger numbers that are a bit less obvious. Although I could divide this by 2, I'm going to use the example. I'm going to use the opportunity to show you how I would do it with different numbers. So I might do a little factor tree. What numbers multiply together to make 36? Well, I can definitely do 1 times 36. I can also do 2 times 18. It's in the 3 times table as well. I can do 3 times 12. So I just work steadily up through my numbers. 1 times something, 2 times something, 3 times something. I can do 4 times something as well. I can do 4 times 9. It's not in the 5 times table, so I can't do 5 times something, but I can do 6 times something. 6 times 6 makes 36. You don't really need to write that 6 down twice, but why not? And then I'm kind of looping back on myself here. When you do that, you know that you've got them all. So those are all the factors of 36, and I'm just going to repeat this for 42. So yeah, I can definitely do 1 times 42. I can do 2 times 21 to make 42, and it's in the 3 times table as well. 3 times 14 is 42. It's not in the 4 times table, it's not in the 5 times table, it is in the 6 times table. 6 times 7 is 42. And I've kind of looped back on myself there, so I know that I've got all of those factors too. Once I've done that, I just look in both of these lists of numbers, and I look for whatever is the highest number that appears in both of them, in the factors of 36 and the factors of 42. And it's a 6, isn't it? 6 is in both of those lists. What that means is that both of those numbers can be divided by 6. 36 can be divided by 6, 42 can be divided by 6. And if we do that, 36 divided by 6 is 6, 42 divided by 6 is 7. Therefore, that fraction simplifies down to 6/7. Okay? It's a little bit long-winded, isn't it? It takes a little while. To be honest with you, if you're good at your times tables, I am very good at my times tables, as you'd expect. I'm a maths teacher, so usually I don't have to write down those factor trees. You know, I can just spot very quickly that both of those numbers can be divided by 6, but I appreciate not everyone is as fluent with their times tables, but I would urge you, if you're not, it's one of the most useful things that you can ever get good at and put time and effort into improving. So if you're not already super fluent with your times tables, I would urge you to persevere with that and keep practicing. Right, I'll just do 1 or 2 more examples, and then I'm going to move on to looking at how you can find the area of some straightforward shapes, squares and rectangles. I'm not going to go beyond that, it's just the kind of basic principles of area. Let's say I've got 24 over 64. So whenever you come across these, it's entirely up to you how you want to do it. You could go through this kind of first method, which is just, right, can I divide them by 2 or 3? And in this case you can, can't you? I can divide them both by 2, 12 over 32. In fact, they'll both divide by 2 again. That will give me 6 over 16. And in fact, I can do that again. So I'll end up with 3 over 8. I know I'm done because that 3 can't divide by anything. 3 only divides by 1 and 3. Well, at least giving us a whole number anyway. That's what we want, isn't it? So 24 over 64 is equal to 3/8. I'm going to do, and that's a totally fine way of doing it. Just back to kind of what I was doing at the start, dividing by 2, dividing by 2. Just to show you how I'd do that if I wanted to do it in one step. I want to find the largest number that goes into 24 and goes into 64. In other words, the largest number that they can both be divided by. And I'm going to do that by finding the factors of those numbers. So the factors of 24, numbers that multiply together to make 24. Well, I can do 1 times 24. I can do 2 times 12. Can I do 3 times something? Yes, I can. I can do 3 times 8. 4 is in the 4 times table as well. 4 times 6. It's not in the 5 times table. Is it in the 6 times table? Yes, it is. I've already written down that 6. So yeah, I'm at that kind of looping back stage. So I know that I've got all of the factors. 64 is a bigger number. You'd think we're probably going to end up with more factors, but possibly not. We can do 1 times 64. Can I do 2 times something? Yes, I can. 2 times 32. And it's in the 4 times table as well. It's 4 times 16. Makes 64. Can I do 5 times something? Nope, it's not in the 5 times table. It's not in the 6 times table. It's not in the 7 times table. It is in the 8 times table. I can do 8 times 8. And I've hit that sort of point where I'm looping back on myself, so I know that I've listed all the possible factors of 64 there. Okay, so we're looking for the biggest number that is a factor of 24 and is a factor of 64. You can see that that is 8. 8 is in both of those lists. That means both of those numbers will divide by 8, okay? So 24 divided by 8 is 3. 64 divided by 8 is 8. So that simplifies down to 3/8. We knew that already because we just worked this question out the other way. But just to show, it doesn't matter which route you go, you will get the same answer. And it's just whichever one you find easier. I would say the second one is really what you want to ultimately to be able to do. And ultimately, you want to be able to do that second one just pretty quickly because you know your times tables really well. You know, when I see that, I can straight away, I can see almost instantly that both of those numbers divide by 8. So I don't really have to go through listing all those factors, just because times tables, I've done a lot of times tables, but super useful. Like I say, I would urge you to do the same as well. Right, that is simplifying fractions. I'm going to move on now to look at finding the area of, it's just a real introduction to area and how we can find the area of squares and rectangles. So first off, I suppose the first question is, what does area mean? Area is just about the size of a surface, really. If you look at this first example, I've got a rectangle that is 4 centimeters along and 3 centimeters up. And we measure area in squares. How many squares would fit into that rectangle? So yes, we've got this rectangle that's 3 centimeters high, 4 centimeters wide. We want to know how many squares fit inside that. That's what our measurement of area is. How many squares fit inside something? And because of the size of it, 4 centimeters, the squares that we're going to talk about are centimeter squares, or square centimeters, I suppose I'd probably say, wouldn't I? Okay, that's really all we're talking about, is how many squares that are 1 centimeter by 1 centimeter will fit into this rectangle. That's all area is talking about, okay? If it's 3 centimeters high, you can see that, well, we would have 3 rows of squares for each centimeter, and it's 4 squares across, sorry, 4 centimeters across. So we would have 4 columns, and there would be 3 rows. So all we would need to do is to count up the number of squares inside that rectangle. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, that's all area is. It's just how many squares will fit into something, because that's the measurement that we use when we're dealing with area. Square centimeters, or if you were talking about something larger, maybe the size of a room or the size of a playing field, something like that, you would talk about square meters. How many squares that are 1 meter by 1 meter would fit into that space, or would cover that surface, I suppose we would say. To the second example, I'm going to do the same thing. Again, it's 3 meters high, so we could fit 3 rows of squares, and in each row there are going to be 6 columns of squares. And then we could just count the squares, but we don't really need to go ahead and count the squares every time, because we can just use multiplication. We know that we've got 6 columns, and in each column there's going to be 3 squares because it's 3 meters high. Therefore, the area of this is going to be, let's go for blue, shall we? If we multiply those two together, that's going to tell us how many squares there are. We've got 6 across, and each of those has 3 squares in, so that is going to be 18. Ooh, I run out of desk there. 18 square meters. 18 squares that are 1 meter by 1 meter. That's it. It's really straightforward. I think I've kind of gone into this explanation because from my experience as a teacher, I've found often people haven't fully grasped what the kind of basic concept of area is. They've remembered that you have to multiply numbers together or something like that, but without really quite understanding why. So I think it's worth taking a moment just to sort of think about why it is that you multiply those 2 numbers together to find the area, so that you're not just kind of blindly following this, this thing that you've been told to do. Hopefully you understand it. Right then, I'm going to do a few more examples of this, and then we are going to wrap it up. So I've got two rectangles again, and we want to know how many squares would fit into this first rectangle. Well, I don't need to draw them on now. I've told you what the rule is. You're just going to multiply those two numbers, but just to sort of drive home that point of why you would, we've got 2 rows of squares, and in each row we're going to have 7 squares. So we've got 2 rows, 7 squares in each row, so that's 2 lots of 7, which is going to be 14. And the area, therefore, is equal to 2 meters multiplied by 7 meters. That is 14. And 14 what? It is 14 square meters. All right, your teachers probably tell you off frequently that you have to put your units down, and they're quite right, you do have to. Right, 3 millimeters. So we're talking small squares now. That's a millimeter, well, approximately a millimeter. 3 millimeters and 15 millimeters high. How many squares are going to fit into this? I'm not going to draw all these in, but you could see we would have 3 columns of squares, and then there would be 15 of those small squares going down. So the area is just right over here. The area is 3 millimeters multiplied by 15 millimeters. 3 times 15, well, it's 45, okay? 45, and that is square millimeters, or millimeters squared, you could say, either way around, really. That is it. Very brief, just a little introduction to the key concept of area, what it is, and how to work it out in simple examples. If anyone has a request to do a bit more on this, I'm very happy to do this, to look at, say, triangles, and then we can look at circles as well. It's the exact same idea. I'm not going to go into it now, but just to show you, principle doesn't change. If you want to find the area of a circle, we're still talking, that's a terrible circle, isn't it? We're still talking about how many squares would fit into a circle, but you can see we've got all these little kind of odds and ends around the edge that we're going to have to account for. So we've got to kind of, it's almost like we're going to chop those extra bits up and put them together, see how many squares that they will form to make, but we have a clever technique to do that. Wonderful. Right, there we go. So if you've got a request for anything, let me know. I will do my best to cover as much as possible every week, and that is at 5 o'clock every Sunday on Facebook Live. And then I upload that to YouTube on Tuesday evenings. If you're watching on YouTube, I'll put a link to the Facebook down below, but I'm very happy for you to make comments or requests on either of those places. And I think that's everything. If you've been watching, thank you very much indeed. And if you haven't checked out my YouTube channel yet, please do. I put a huge amount of time and effort into those videos, and I hope they're useful for you. I shall see you next week on Maths Kitchen Homework Club.